Hi everybody, welcome to our talk. Get a grip on your hustle, the Glassdoor exfiltration toolkit. So, who we are. My name is Kyle Stone. My friends call me SOB. You can find me on Twitter. I like to retweet credit cards. Some people find it hysterical. Other people not so much. Dropped my first O-Day last year in this very room. I founded a Louisville organization of Lock Sport. I'm a member of LDN 303 HHS.
I'm Parker Schmitt. So I work as a pen tester. I am into networks, virtualization. I love Gen 2. And everyone will give me trouble about that, but I am a total Gen 2 fanboy. Also total math geek, love crypto, love Stego, love designing algorithms. And oh yeah, and I also like hacking Wi-Fi from drones too.
Hello, I'm Chris Hodges. You can find me on Twitter as Glitch, spelled GL11TCH. Used to be in the Army, now I'm at Accuvant. Greatest move ever. You can see that wasn't sarcasm, I swear to God. Like, I'm mad nervous. A lot more people than what I was expecting. So, all right, so I visited Exploit database a few times and left some stuff behind, so you can see that. Yeah, it looks like that's it for that.
So why do we care about exfil methods? Exfiltration overall is mostly ignored. Everyone loves to pop a box, but attackers care about it a lot. That's your data leaving your network. So why do we not concentrate on that? Why is the part that removes value from our companies mostly ignored? It's not sexy, but it could be. So how do you measure detection of known exfiltrations? How do you measure it within an IR team? How do you measure it within Blue Response? How do you measure the response time post-exfil? How do you show value in training your analysts to recognize this data, right? How do you put benchmarks against that? How do you implement known methods to share with colleagues? I mean, everybody heard what happened at Target, right? You know, who here wouldn't have saw that, right? 11 gigs of FTP data over 2 weeks. Would your IDS have caught it? Would your DLPs? You know, that's a fair value question. You know, people need to find value in working with their analysts. They need to show value in it. So if you can't measure it, you can't show the value in it.
All right, so the other issue is with egress used to be a lot more trivial than it used to be. I mean, it would just be reverse TCP, just connect to a web server, you're done. But nowadays, people are putting more on their edges. They're actually scanning for packets. And so in addition to finding ways out, we need to actually step up with our game. We also need to evade IDS and IPS, because now that's over the wire. Now, one thing is, if you end up having SIGs, because a lot of times IDS and IPS have SIGs. So a way to get around that is we make a modular framework where we can keep adding exfil modules so that every time someone figures out one way, has SIGs for it, we just make another. Plugs right into our tool still works. You just have to do a little bit more work each time, but you have a new payload each time.
So the end goals we want to arrive with the framework are modular egress methods, multi-architecture payloads, multi-OS payloads, runtime encryption, mutating steganography, rarely observed channels, streamlined deployment for those payloads. What our end goal is to facilitate as a tool for pen testers to show that an exfiltration can happen and that it may or may not be detected by your tools. In addition, IR teams can use it to pass around known exfiltrations without handing PCAPs around. I mean, everybody scrub PCAPs. It's kind of not fun. So, Exfil. Exfil is hard. Why is it hard? Well, there's a couple ways around that. You can hide in plain sight, but mostly we're evading detection from outbound filtering, from proxies, from log analysis, from DLP, from IDS, firewalls. So how do we do it? How do we hone our exfiltration skills to make this happen?
How do we do it, Bob?
Can we do this one?
All right, so we're talking about how to exfiltrate. Of course, that's a how-to basic from there. Got to throw one in there because they're just always so funny. And so one thing is, if you have to sometimes go through data paths, you can be seen. So how do you hide it? Well, it turns out Stego is not just for CTFs anymore. On the red side, you don't necessarily have a legit use of crypto. So you got to hide your exfiltration. You know, if something's a picture of a cat, you have all sorts of sensitive data in a picture of a cat, your IR team might just see a picture of a cat in there. And of course, we have less inspected paths too, because I mean, no one suspects the VoIP phones, but they're usually a lot of times plugged into your same network. So you could actually, even if it's slowed, like going through DTMF, and we actually wrote an encoder for this, but you can go through DTMF and dial out a key. So now you can actually like divine your Stego algorithms on the fly through DTMF and then send something through an image. So we can use both plain sight and non-plain sight paths at the same time.
What does DTMF stand for?
Sorry, it's a dial tone. So it'd be like, thank you for calling 1-800-EXFIL. Please dial your 35-digit account number. And then, of course, and bytes are encoded in that. All we had to do is turn that from base 16 to base 12, and you can just dial out. And so, you know, so when you're trying to hide in plain sight, how do you do it? So you got to just seem like normal user behavior, you know, including stuff of users not working, like browsing YouTube and stuff. That's normal user behavior. So that's how you generally want to get out, because then there's nothing suspect about it. And so a lot of times it's, you know, sending an email. No one suspects that. A lot of times emails over SSL. Commenting on YouTube is another one. You can even hide stuff in your YouTube comments too. We'll show that in a little bit. You know, people get on CNN, Twitter, GitHub, and you might say, well, let's just block all these services. Let's just block all these web applications. Well, first of all, your employees might not be happy. Second of all, your marketing people might say, hey, there's a business need for social media. We need all this. We need to make posts. Well, now there is, even if you're whitelisting, there's a path out. You can type data out onto just a web application, and you have an egress path.
So another example we were working on is exfiltration or C2 over Gmail. Ultimately, what you receive is high bandwidth data transfer with high latency. There's trade-offs in all inspected and uninspected data paths. Do this one.
I got this. So what I ended up doing too on what I ended up doing here is looking at steganography and how we can advance it to being able to use this. Because quite honestly, the Stego problems with CTFs, the goal is to find the flags. Now, in real life, we need to make this as hard as possible. And there's a few things different in Stego versus crypto. One of the things is you know how they say never implement your own crypto? Well, if you're trying not to be caught using crypto or using Stego, you want to implement it yourself. So we're trying to one of our goals is let's find a way so that you can implement your own Stego without implementing your own Stego. So with least significant bits, yeah, you're going to get your original image tainted the least, and it's the most efficient with data. But everyone knows that there's the least significant bits. So if you don't use all of them, you use a random sequence. If, you know, in combinatorics, we can calculate, okay, well, that's m choose n. So if it's a big file and a big payload, there are huge amounts of possibilities of different ways this file is encoded. Now, let's say we encode 2 bits in some bytes, 1 bit in others and 0 in other ones with a random sequence predefined both on the server and the client. And, how can we get that sequence across? Well, there's many ways, as we've shown. We can do a YouTube comment, we can do a tweet, we can do a DTMF. It can dial a phone. You can dial a phone out and say to the attacker, "Hey, this is the key I've randomly chosen," hooking in the random function on the OS of the machine you've owned. And so, at this point, steg analysis is really, really hard. Now, maybe a good mathematician could find a flaw, and so we haven't completely proven everything we're working on here, but quite honestly, cryptanalysis takes a long time. And by that point, you're too late. It took 2 weeks for Target to get owned. I mean, I know you've probably solved some crypto challenges in CTFs which are designed to get solved faster, but I mean, like AES implemented the wrong way. You can sometimes break it. It just takes a while.
So next we have less inspected data paths that we're looking at implementing. The pros to less inspected data paths are, well, low overall inspection rates. Nobody expects the Spanish Inquisition. Simple protocols to work with. The cons, generally low bandwidth. Some require near locality. For instance, if you're doing Bluetooth egress, AP beacons, software-defined radios, audio. The other side of that is anomalous behavior. If anyone looks, you're likely going to be found because the data paths don't facilitate lots of data. So generally the logs are much more quiet, if there are logs. So another method we were looking at was Exfil C2 over audio. Again, like Parker said, 1-800-DATA-EXFIL. Please enter your 45-digit user ID. Exfil over DTMF. Exfiltration over FSK modems. Anybody remember the old caller ID bleeps or POGSAG or any of that stuff? Yeah, you can play that stuff over a PSTN path in narrow bandwidth and exfiltrate data. It does work. I've done it. You can also go wideband. If you have point-to-point VoIP and they're doing extremely wideband codecs, you can shove a lot of data in those, a lot. And so take from bad BIOS, you can mine the gap. You could do a 23 kilohertz offset carrier FSK and do ultrasonic from laptop to laptop.
Could always hire a dog on your IR team. So we're looking at inspected data paths, which of course we said before is paths that are going across all the egress filtering, all the blinkies. So one thing with our methods, it's easy to simulate realistic traffic, especially like in a large organization. There is a lot of data going across. It's hard to really see anomalies. And so also, do you really expect exfil over memes? We haven't seen that before, and people are like, oh, those are just PNGs. Someone's just not working. By that point, it's too late. And so it's hiding, we're hiding in user-generated traffic because in this situation, or in a post-exploitation scenario, you have endpoints in the network that are already owned, and you're trying to get traffic out. So if you look at like the users, it's just their normal laptop traffic, and it's just from desktops. We're just getting it out. We all played around with getting stuff out of Windows. We're in that environment. People have written payloads for Windows all the time and hooking the browser and everything else. So, of course, we do have some cons. So logs do exist. Now, one benefit we have over our stuff is, well, what's in the logs? If the logs are recording stuff over the wire, well, there's not as much. We're using Stego, we're using random manipulations of data being sent over. So, but they will exist, and someone could eventually reverse engineer them over time. And so, if their heuristics actually can see our evasion, like they can see our techniques, they can see one of our tools. Yeah, they might be able to write some SIGs. We could evolve them, put new things in, but it is always a game of cat and mouse, you know. Hey, the attackers are doing this one thing. Let's put something in to stop it. Let's drop a rock in there. Now let's go to something else. And so it will be a little bit of a game of whack-a-mole, but we're hoping that we can win that race with this. And another con, so from a server, you're not going to get web traffic from a server. Just like, you know, when people are saying, oh, we're going to spoof the printer. Well, people, if IR teams are doing a good job, they'll be like, hey, why is this server signing on to YouTube? Something must be up there, or you have a sysadmin that's not doing their job at all. So at that point, so you do have to pivot out. And we've seen that in breaches before, that it goes through a server, back onto the owned desktop, and then sent out. And a lot of times the desktops aren't logged nearly as much as the servers are. So I'm going to let Kyle tell you about our overall plans.
So where we're headed, as a post-exploitation and exfiltration frameworks, what we would like to see is assist blue teams in honing their detection times and their techniques. We would like to be able to introduce new algorithms easier. So red teams who are trying to give an example of exfiltration can slap down a quick algorithm and say, look, I just shoved 10 gigs out over here and nobody noticed for a week. Also, we would like to see the framework help evolve to so that pen testers can try new evasion techniques easier with less work. Like, so you have all the structure there. You don't have to recreate your covert channels if you want to create a new steganography library. And we would like to eventually see it easier to share that work with others. Just the same way that SIGs get passed around very rapidly when an O-day drops. A breach occurs, there's no reason they shouldn't be sharing that information. You can't stop Exfil if there is an egress path. Ultimately, as long as there's a way out, you can't stop it. You can't stop O-days. They will happen. So who else is looking at this type of stuff? There is PowerSploit, which is Windows and PowerShell focused. It's really neat. If you haven't seen it, go take a look at it. There's a router post-exploitation framework. His is more oriented towards embedded hardware. I'm a bit of an embedded hardware nerd. Postsploit FW. His technique is turning C++ into more of a scripted system host driving language. So it's to build payloads and to make them easier to build them. Nearly a scripting like syntax with C++. So how do we stop this? I don't know. But how do we exfil? You know, don't ignore your SIMs. You know, watch your alerts. Tune the hell out of your rules. But everyone needs tools, but ultimately understanding how they work and how they work in other scenarios would benefit all of us. If you don't know your tools will sound off for an exfil, go write up a POC for it, shove it in, test it, say, oh look, blinky box number 1 worked, number 2 didn't, number 3 didn't see it either. We may have a problem. Train your people. Ultimately, training your people to detect exfiltration is what your real goals are as an IR response blue team. Invest in them. Invest in them heavily. Run tabletopping between blue, red, IR. You all should be collaborating together. You know, your red teams should be helping your IR people know what exfils look like. I'll be honest with you, if I was running an IR team, I'd put gamification in it. I'd say there is a beacon somewhere in your network. If you can find it, there's a day of PTO for you. Good luck. Run internal CTFs. You know, it's more than just staring at staring at an email and doing cryptanalysis on it, or staring at a PCAP. You need real live scenarios. Nickerson said it best, really. The only way to prepare for a fight is to get into a fight. And tabletopping will only take you so far. You know, it's difficult to simulate a real environment for IR. So log everything. Full PCAPs or win. Host-based protections. You know, concentrate on the internal instead of the edge. The edge isn't everything. Anomaly detection. If anybody's looked at new anomalous stuff, there's a genetic encoding for log files now that is aiming to aid in analysis for anomalies. Go look at Blarpy. It's really cool. Invest in your analysts and your tools. You need tools, but you need your people to understand how they work and how they run.
Also, just adding to the host-based, to the focus on host-based is, so let's say someone has a steganographic reverse payload installed on your endpoints. You're not going to see it nearly as well on the prim, and especially because a lot of times things are encrypted over the wire because a lot of stuff's going to HTTPS. I mean, there's even rumors that they might even try to remove plain text HTTP from the standards. I don't think it's going to happen. It would be nice. But so if you have host-based protections, looking what's egressing from each of your employees' machines, you can then say, oh, well, that's weird. One of them stands out, because then you have individual data points, and then you can say, okay, this one's sending way more than the other one. But that means you have to go one layer deeper onto the inside. And I'll give it back to Kyle for this.
So our current toolkit timeline. The project is currently in alpha. We will be adding to the structure of the toolkit over the next several months. Ultimately, what we're looking for is a Python modular structure that will be as following. Receive and transmit channels. Data channel encoders, encryption, and steganography. Payload building. Runtime payload encryption. Accessory modules such as evasion timers and egress seekers. We would like to make it so that when you could set a path of best to least that you would like to try. So we're going to try to tunnel out over YouTube comments. Well, that doesn't work. Okay, let's go to Google Mail. Oh, I can't get there. Okay, let's try Hotmail. Well, that doesn't work either. Hey, let's check Wikipedia. Oh, great, we can exfil over Wikipedia comments. Great. Evasion timers. Generally, there's going to be different facets of the evasion timers. We'd like to see some where it revolves around figuring out when to send data. So if you see that people are sending data 9 to 5, you're watching egress egress traffic, right? So if you're pretending to be a user, you want to send that data during that timeline. Outside of that, if you don't want your timer to go off once an hour every hour, because somebody's going to see that. They're going to be like, oh, that right there, that's bad.
So like mention something on the egress seekers is so like dumb it down for me anyways is if like you come back from lunch every day and you go to your workstation and sit down and you go out to like Wikipedia, all right, well then that's going to be, you know, the avenue we take on that workstation. But like, you know, the coworker next to you, you know, comes back from lunch and every day, you know, gets on and, you know, checks like Zillow or whatever for like house hunting. Okay, well then, you know, that's the route we're trying to take, or YouTube into those comments. So it's just not like a randomness, you know, there's actually like something to it, you know. You're using anomaly detection to, you know, to protect yourself or whatever. Well, we're using that same, you know, avenue, I guess, just, you know, reversed to find our way out.
So currently where we're sitting, in about a week, we're going to drop the source code. We've got another pending media engagement that we're waiting on before we drop it. We're aiming for a 1.0 release somewhere around the summer of 2015. We would like to see it stable with plenty of modules, both on the easy side and the harder detection sides. Upcoming is Black Hat Brazil. Want to talk about what you're doing up there?
So what we're going to do up there, and we might see if we can give this at somewhere in the U.S. too, is we want to end up. So a lot of times with some payload crypto frameworks, they use something like AES. Now there's a problem with that because AES is a permutation table. So does DES, because you're trying to do what's called diffusion in crypto, so you can't do what's called a known plaintext attack, where you guess the plaintext. Because a lot of times you have ideas of part of the plaintext, such as in an HTTP connection, there are headers. You know what a lot of them are. You could browse to that same page and see what's there. So that's why they do it. But with a payload, well, with a lot of dynamic code analysis, it can say, hey, you're mapping this byte to this byte, this byte to this byte. I know that pattern. That's crypto. Why are you decrypting a random flat file on this user's desktop? Hey, you got an alert. And so what we're trying to do is generate different crypto algorithms and just using some maybe even simpler crypto algorithms that are harder to detect, and then with some randomization actually like try to generate algorithms on the fly. And I'm also going to continue the Stego research and make it so we can actually like generate algorithms on the fly, use variants of different public key cryptos to send information about the algorithm to use, and then almost de-optimize code so that it doesn't get detected. Because a lot of times when we're doing AV evasion, we're actually de-optimizing code just so that it's harder for anything to see. Because there's a lot more entropy when something's not optimized. When there's optimized, well, there's obviously the perfectly optimal code. And that's the smallest. And if something's close to that, well, it's easier to see. And then after that, I think we're going to talk, like in another time after that slide, we're going to talk about how to go through web applications. And also we'll be talking about like how to actually, so instead of using SMTP, how about having your linking into the browser, browsing to Gmail and sending an email? I mean, how many of you guys are allowed to go onto blogs like WordPress, YouTube, Gmail, and there's usually a business case for it, right? Sometimes you have to learn how to do something. Well, you can always type comments. It's really hard to make filters for that. And so even with the whitelist, if you can get data out somehow, and you can put it in plain sight, you can always find a way to just pull it back down somewhere. The attacker can pull it back down, post something. The attacker can tweet something. We've even seen Twitter accounts like Password Turtle, if any of you have seen that. Like, who would use a password from Password Turtle? Could that be an egress? We don't know. But it's just like a whole bunch of random characters are going on Twitter. We have seen multiple accounts doing this, like just browsing through there. And 4chan, I doubt you can get there at work, but that would be a damn good place to hide data. Though, no, don't.
Exfil over me.
All right. Oh, so in Black Hat Brazil, we're actually the algorithms will be generated on the fly. So, and then eventually our goal in that summer is to be generating payloads just on the fly. So you can almost make, I don't want to call it malware, but like pretend malware for your IRD team to test. Or if you're on a pen test, you can just like use this to win. So you can use this to get data out ways people have not seen it before. Be like, okay, so IR team, we are going to simulate the target breach. We might even have a module that says, okay, we're going to infect a server the same way the target breach happened. See if you can find it. And maybe in a more evolved business that is more security aware, they might even say, okay, we are going to have random scenarios with this, malware, but pretend malware on your system, and you guys go find it. Now the benefit of that is, so a lot of people have done fake phishing campaigns, and some fake phishing campaigns are able to, employees will report something saying, hey, that's phishing. But they're like, that was not our test. Turns out it's a real phishing campaign. Ben 10 did a talk about at ThoughtCon about how they had fake phishing campaigns and actually caught the real ones. So maybe something like this, using this as practice, your IR team will catch the real thing.
So demo time. Here we have part of the POC from Python using our framework. I'm going to play this because it is not live.
All right, so what I did, I just put the Tale of Two Cities, just part of the first page, and just put it in there. So we just put that in our library, made a text buffer object, and then we just wrote a little SMTP POC that sends the data through there, encoded in drunk type. And so what happens is, so with drunk type, you end up having, so you're typing along or texting before autocorrect and you hit the wrong keys. It's always what's next to each other. I mean, I'm sure everyone has had someone drunk text them, or on the other way around, drunk texted someone, drunk IM'd them. So, well, what if you can misspell a word and it means a 1 and a correct letter is a 0? Well, it's not that efficient. Like, you're losing, the file is 8 times bigger, but you can put a lot of data in there. The one thing that I did that wasn't optimal for our stego there is I just had least significant bits there. Now, the reason that's wrong is you can detect it. I wanted to keep it simpler so that when we drop the stego library, which I'm eventually going to rewrite it into a library, and it will support random stego, I wanted to be able to, something can see, oh, this is how it works. So they can understand how things work. Because we want people to, instead of just saying, oh, let's just run the tool, learn how the tool works. Learn how to make these payloads so that you can actually evolve them. And if you have some crazy idea like, hey, what if I could tunnel through this? Well, we'll have the framework there to help you. So right here, you can see that an email sent, and it's, instead of it was the best of times, it was the worst of times. Now, the reason the guy is extremely drunk, whoever's sending this, is because I didn't put enough space. Now, what if I just had every other letter be able to encode? Well, that would still be like it was the best of times, it was the worst of times, and so you would be able to see more, and it would look more like plain text. Now, ways to evade just drunk type in general, well, there aren't any. I mean, you could see like someone sending a lot of text, but if you are like checking YouTube comments going out and have a spell checker on your IDS or on your proxy, I doubt that's worth the investment. Some people who are like extremely perimeter focused might go there, but oh wait, YouTube's now over HTTPS. Almost all these web applications are over HTTPS. So now you have to man in the middle. Now, what's the problem with that? Well, if you have a device that's man in the middling everyone, well, you have to better protect that device well, because someone owns that device. They can put whatever they want, the request. Now you can see in here the drunk type. And of course, we encoded a meme. You could also do stego over there. We didn't implement that in this, but of course we had to have that in there in honor of Dave and all the what he's been doing, warning everyone about healthcare.gov. And we wish people listened to him more. What? Oh, and we did implement TLS. Now there's one argument is, do you use TLS? Now, why am I saying why wouldn't you want to encrypt it? Well, what's more suspicious, an encrypted message being sent over your edge or plain text? If you're sending something in plain text, you're saying like, I got nothing to hide. I'm posting it somewhere, but IDS is going to go more after sending something encrypted. But also sometimes, in theory, that's better. We implemented TLS because in practice, like look at the Home Depot breach. They just encrypted everything and sent it over the edge, and it was all gone. And we're all thinking, come on, Home Depot, it's SMTP. You probably have an internal mail service. Why are you doing that? But some people aren't even that far ahead. They aren't even blocking egress. So you might be able to get away with more evading logs doing TLS. So there's an argument to go either way. And it depends on the target. We can show them the DTF photo too. Or we can do that later. Okay, we can show them the on there.
Yeah.
I would like to insert a funny joke here. Everyone laughs. It's gone.
There you go.
All right. So one thing we did. So over the last month or so, what we've been doing, because we had to figure out, okay, what are we going to send? Because there's so many ways out of a place. You know, if you have a big locked door, what's the easiest way to open the door? From the inside. So we've been going through a lot of different techniques, but one of them is how to encode into DTMF. So, and I'd like to show that if I can get the two screens figured out. I'm not a Mac guy, sorry. Oh, it's just on there. Okay. Thanks. All right. So let's go. Okay, let's just see what we have in there. So I'm just going to run a test on that. I just fucking go. Okay, I just have to remember my function names because I want to do a demo because I just made a library for this. All right. So what we can do is go. Yeah, it's going to be on GitHub. We have some stuff ready. I'm going to change a couple stuff. I'm going to have some of the Sego stuff. We're going to have a DTMF encoder. We're going to have the SMTP one up. And by next week, we should have a lot more up there. And so that's our timeline. We got a media obligation right now, too. So let's just see. Hopefully this will work. Let's pray to the demo gods. Oh, thanks. Yeah, sacrifice your goats, sheeps, everything. Oh, my bad. This just so you can encode a byte in. So okay, that's 131, of course, in binary. But see, I just did 0, £, We also have a function that you can just like pop a byte array in there. So let's just do that. Right, let's scroll up in this. Oh, yeah, we have the old version in here. Whoops. All right. But yeah, the other version I promised you on GitHub does have that. We just didn't do a pull at the right time. Because somebody here was doing the bash attack on the wireless, so I didn't want to get on there because I noticed my resolve.conf had something. So someone was playing on the Louisville Hyatt network.
It was 4chan. That's who it was. Those hackers.
All right. This is, I would like to give out some thank yous. AccuVant. All right, as well as DerbyCon. 303, HHS, LDN. See, all our family, friends. Sorry, I'm crazy nervous. Anyways, seriously, I'd like to thank my wife and my kids for putting up with my stuff. My very forgiving boss. Again, DerbyCon, I love this place. Look forward to this year round. All of the present, future, and past veterans. My two friends here. This has been a serious adventure, and that's all I have. Anybody? Does anyone have any questions?
I'd like to thank my wife too, and my boss, and my coworkers, and my kids, and everybody who comes to my party every year. Thank you guys.
And also, if you know our work, the reason we're dropping this all to GitHub is we can't think of dropping a lot of the stuff to GitHub is at some point. We can't think of all the crazy exfiltration paths, so we really hope that people are willing to add to this. We'd like to put the framework there, and it's in Python, and Python's pretty easy to code. Import anti-gravity. If you're familiar with XKCD, like how are you flying, Python. So yeah, feel free to contribute. We would love that. We'd love to keep growing this and actually make this a full-fledged post-exploitation framework at some point.
So we've got 5 minutes left. Are there any questions? Yeah, so one of the ideas that we had would, okay, so you pop some random mode on a Windows box. You start monitoring what the user is doing through keyboard hooking and compare that to where they're going and what they're doing, right? So if they're going to gmail.com every day at 3 o'clock, I'm just going to send an extra packet or extra transaction that's going to cause an email to fire off that's going to exfiltrate some data. Now the odds of that getting saw, because that's a very noisy transaction, is going to be very difficult. That would be ideal for trying to train an IR team. Hide it. Can they find an exfil in a haystack? Anybody else in the back? Yep. I'm sorry? Obviously, you wouldn't want to shove real data out, but if you're the one in control, you can make a generated payload that looks exactly like your real data.
Don't leave us, bro.
Yeah, don't leave us, bro. There's plenty of stuff out there that'll do that for you, that'll help you create synthetic information that looks real. Yes. Yes, so we would like to try to draw in community support. Like he said, we can't think of everything, whether it be ideas or if you want to do some coding, we would really appreciate any help anyone would like to work on. So anybody? It is not public yet. We have another pending media engagement, and it will be dropped after that. So roughly in about a week.
Just follow us on Twitter.
Yeah, follow us on Twitter, ESSOBI, Parker Schmitt, Glitch. We'll trust us. We'll spam it. Anybody else? Yeah. Thank you. Have a good con.